Okay, I'm going to record a video for Unit 10, Circles Part 2, and it's another short unit. It's got, we're really figuring out all these missing angles in here, and there's another part where we're going to be figuring out all the missing side lengths or segment lengths. So actually I'm going to start with, even though in class we didn't start with this, I'm going to start with the vocab words, which is on the back of the second packet. Okay, so some words we went over the first one in the first video were radius. So radius, remember, is going from the center of the circle to a point on the circle. So AP would be a radius. And then we also talked about a diameter, which goes through the center of the circle. Let's see if I have a diameter on here. So a diameter would be like segment QS. We talked about the third type was a chord, which is a segment that has both of its endpoints on the circle, and it's a segment that has both of its endpoints on the circle, so PS would be a chord. And we also talked about, well, just what a circle is. So it's a set of points equidistant, the same distance away from a center point T. Okay. So these are some new vocab words that we're going to use for the second part of this circles topic. So Unit 9 was part 1, Unit 2, this is the second part. So we have a central angle. So an angle that has its vertex, which is the center of the angle, where the two sides meet. At the center and the two sides are radius, so each of these are a radius. That would be a central angle. So angle APB, this angle, would be a central angle. An inscribed angle is an angle that has the vertex, the middle of its sides, on the circle. Hey, Kelly. And the two sides are chords of the circle. So unlike this one where it's meeting in the middle of the circle, this one's going to meet on the circle, so this would be our inscribed angle, angle ACB. Okay, then we had arcs. We talked about arcs last unit, but just to go back a little bit more in detail, a portion of the edge of the circle. So A to B would be an arc, and our symbol for that is just, it looks like a curve of a circle. If it's a minor arc, which means it has a measure less than 180, so it's less than halfway around the circle, then we just need to use two letters to name it. So AB, or we could have arc BC, or even AC. If it's a major arc and the angle is greater than 180 degrees, we would use three letters to name it. So that would be like arc ACB. So these two things, they use the same letters, AB, but this one only has two letters because we're going the shortest distance we can. This one, ACB, uses all three, so we trace the letters in order. So we start with A, go to C, and continue in the same direction to get to B. So the major arcs usually will have three. Okay. And then we have three more vocab words. So secant, some people like to say all fancy, is a line that intersects the circle in two places. So it's very similar to a chord. The difference is that it extends past it. So the chord is a segment, the secant is a line. So this one continues past the circle, the chord ends on the circle, and it's just XY. Okay, so the chord for this would be XY, but the secant would be XY with the line symbol to indicate that it continues past, secant, past those 2 points. Okay, a tangent is another line, so it continues in both directions. It intersects the circle in exactly one place. So it only has one point where it touches the circle, which is point Q. The tangent is always perpendicular to the radius, but we'll get into that. So because it's only meeting the circle at one point, it's meeting the circle at a right angle. If it met it at any other angle, then it would really be very slightly intersecting the circle on 2 points, or not intersecting the circle at all. So if there exists a line that's perpendicular to that point, and that's the radius. And then the point of tangency is point Q. It's the point where the circle and the tangent line meet. Okay. So that was on the back of this second packet that I gave you. But this reference sheet is going to be key for us to fill out this first packet. So the reference sheet has on it for us, for each of the types of angles, what you would do to solve for missing arcs and angles. So again, the angles are formed by three letters and they have this symbol. The arcs are 2 or 3 letters and it has this symbol. In this particular case, central angles they have the same measure as the arcs. So the angle here, ABC, this 100-degree angle, is the same as the arc A to C, which would be this arc is 100 degrees. Okay, so 100 degrees, the central angles are the exact same as the arc. The inscribed angle, if the angle goes all the way to the circle, the vertex of it goes all the way to the circle, is half of the measure of the arc. So we still have an arc AC, let's say it's still 100 degrees. If we were just come to the middle, it would be 100 degrees, but we get all the way to the corner, so we have to cut it in half. So you take half of the arc, which was 100, half of 100 would give us 50. So the measure of angle ABC, this angle is 50 because it's half of the arc for inscribed angles. Okay. Even if two, so let's overlapping arcs. So like, let's look at this arc AD. For instance, that arc is opening up from two different angles. So if I cover up the sides of this, it's the opening for angle B, because the sides of angle B point to those. So if this angle B was 40 degrees, based on what we just did here, if the angle is 50, this was 100. So if the angle is 40, ignoring this line C, if the angle is 40 here, this is going to be 80. So this arc is going to be 80 degrees. And then notice that C also opens up to the same exact arc, 80. So that means if you cut 80 in half, this will be 40. So two angles that open up to the same arc must be equal to each other because you're cutting the same number in half. So in this case, angle ABD, which is really referring to angle B with the sides BA and BD, and then angle C with the sides AC and CD, they will be equal to each other because they're opening to the same arc. Okay, then we have three more cases where we have an inscribed quadrilateral. So inscribed means the quadrilateral is inside, so inscribed has got the same prefix of the circle. And the significance of that is that the two angles opposite each other are equal to 180. So let's say that this is a 70-degree angle. A plus C has to equal 180, so we plug in 70 for A. And then in order for it to equal 180, we need this one to be 110. So this would be 110 degrees. And then for B, these two have to equal 180, so I have to give you one of them. Let's say I give you this one as a 85-degree angle. I know it looks obtuse, but I started writing 85, so we'll just roll with it. Then if this is 85, then that plus something has to give me 180, so this is going to be 95 here. So this will be a 95-degree angle. So the two opposite each other, these two have to make 180 together, and then the other two have to make 180 together. So opposite angles for this are supplementary. Okay. All right, the next one is if you have intersecting chords or secants, so two lines that go through the circle, but they don't cross at the middle. So if they cross at the middle, it's just going to be that the arc is equal to the angle. But if they don't cross in the middle of the circle, say this is the middle of the circle, and they cross somewhere else, but on the inside, then you're going to average the two arcs that each of the angles opens up to. So what I mean by that is angle 1 is going to be the measure, so the degrees for this and this, both of these are the same because they're vertical, is going to be equal to half of these arcs added together. So if this arc is, let's say, 50 degrees, and this arc is 70 degrees. Okay, they'll give you the two arcs, or maybe they'll give you the angle. But you would add the two arcs, so AB was 50 and CD was 70, so we would have 120 if we add the two arcs, and then we would divide that in half. So 120 divided by 2 is 60, so this would be 60 degrees in here. So to find an angle on the interior that's made, you would average the two arcs that it opens up to. So add them and divide by 2. Then angle 2, you do the same thing, but if I don't give you these two have to make 180 because they're right next to each other. So if this is 60, the one right next to it has to be 180 minus 60, or 120. Okay, because remember, all four of these have to total 360, and vertical are equal, and the linear are supplementary, which means they add up to equal 180. All right, then we have intersecting tangents, so a tangent and then either a chord or a secant. So we have a tangent here, and then this line is a secant or a chord if it stopped at C. They have the same formula as the inscribed angle because their vertex is on the circle. So it's just like this one, the vertex is on the circle. So you're going to cut the arc in half. So we would take this arc, let's say it's 250 degrees, and we would cut it in half. So we take the arc and divide it by 2 to get the angle is 125 degrees. And then angle 2, you do the same thing. So the rest of the circle, if this is 250 on this side, the full circle has to be 360 all the way around. So you would do 360 minus 250 to get the rest of the angle, or the rest of the arc, I'm sorry. So that's 110, and then we would cut that in half, so this is 55. Or you could just say 180 minus 125 is 55, so that's angle 2. Okay, and the last three formulas are the same. You subtract and then divide by 2 for all three of these. So if your circle, if you're looking for the angle out here and your circle has an arc here and an arc here, you would do the large arc minus the small arc and you divide that by 2. So let's say this looks like about maybe 140 and a 30-degree angle, or arc. If I do DE, this is 140. So that large arc minus the small arc, which gives me 110, and then I divide that by 2, or cut that in half. So this would be 55 degrees for angle A. Same thing if you had a tangent intersecting with a secant. You do the large arc minus the small arc divided by 2. So let's say it's close to 180, it looks like a semicircle. And then this one maybe 60 degrees. So I would do 180 minus 60. And then 120 divided by 2, so this would be 60 as well. These don't need to be the same, but it just happened in this case that they were the same. Okay, but it's a large arc minus small arc divided by 2. And then this one, they only have to give you one thing, because if they give you one arc or angle, so they give you that this is 240. Well, let's make it 260 so that doesn't come out to 60 again. So 260. Let's say it's 260, they give you that. Then to get this part, you would do the rest of the circle. So you would do 360 minus 260. So that's going to be 100 degrees. So you can figure this part out by subtracting from 360 if the two tangents cross and make an angle. And then you'd be filling this in 260 minus 100. So 160 divided by 2, which will make this 80. Okay, so those are all of our angles, circles, references, formulas that we need to reference. It's kind of a lot, but if you fill that out on your sheet, then you should be good. Okay, and then what we're going to do is we're going to try to figure out which of these formulas applies for each of the problems. So on these, we're relating arcs and angles, so we're looking for arc ST, which is this arc first. And the angle they give us is a central angle because the center of it is in the circle. So it's like this kind, where the angle is the exact same as the arc. So if that is given as 122, then ST is 122 as well. And then RS is the rest of a semicircle. So a semicircle, this would be 180. We said this is 122. The rest, the semicircle above would also be 180, and we need to subtract out the 122. So that's going to give us 180 minus 122. So 58 degrees would be this angle and this arc. And then if it says SRT, what it really wants is the SRT. Starting at S, going, I'm going to highlight it so you can kind of see. Starting at S, going all the way around until you get to T. So you want to start at S, you want to pass R first, and then you want to land at T. So it's talking about the 58 degree angle and the 180 degree angle. So we would add 58 and 180. So 238 would be SRT. Okay, for number 2, again, these are central angles because the center of all of these angles in the picture are in the center of the circle. The vertex of all the angles are the center of the circle. So any straight angle is going to make 180. So these two make 180. And then any vertical angles, so this combination of this angle here and this angle, whenever you see an X, the two opposite angles make 180. So then, make vertical angles so they're equal to each other, sorry. So these combined, so the 18x minus 2 plus the 15 would make 103. Okay, so the combination of these two angles makes this, is the same as this one. So then we would evaluate that. So far away, there we go. All right, adding like terms because they're on the same side, we get 13 here. Subtracting 13 from both sides, we get 90. So x will be 5. Just double check. Okay, now I'm going to let you try some of these. I'm just going to do some random ones. All right, on number 5, 4 is similar to 5, but 5 they give us an angle, and they want us to find an arc. So DGF, starting at D, going through G, and then ending at F, is talking about this arc. Well, this arc is opening up from this angle, so that's convenient. So the inscribed angle, if you double it, gives you the arc. So we're going to be using this second formula, and we're given the angle, so we just need to times it by 2 to get the arc. So the arc is 226 degrees. Okay, on number 6, it apparently doesn't have any degrees, but because this is going through the center of the circle, we know that this is 180 degrees. So we are going to have 180 degrees, and the angle that's opening up from that is this angle here. So Q has the if I outline Q, that's the angle, so the arc is 180. So I cut 180 in half, and that's going to be a right angle. So Q is going to be 90 degrees, and that's the one they want. Okay, so you're going to use angle arc, so you double in half different things. That's the first part. But then sometimes you might have to subtract from 180 or 360 to get some missing things. So on number 7 here, they want BC, this arc. Well, there's no angle opening up from that arc. So what we would need to do is figure out a different arc. So maybe get this arc, and then we see that this is a semicircle, so we can solve from there. So if this angle is 47, it's inscribed, so that means we're going to be using this formula. So 47, and we would be multiplying it by 2 to get the arc. So 47 times 2 is going to give us that this is 94 from A to C. We already know from B to C is, or from A to B is 180. So the semicircle would be 180. And we want to subtract out the 94 that we already know. So that's going to give us 86. All right.
I hope everything works out. I'm just afraid kids aren't going to come tomorrow. I just feel like everybody's been so lax about things.
Yeah.
I hope it goes well.
I will.
Have fun.
Thank you.
Bye, Michelle. Have a good one. Okay, so we would do 86. So the rest of this would be 86 because it has to make half of a circle. So 360 would be the whole circle, and we only want half of it, so we want 180. So like this also would be 180 on this side, but we don't care about that. So BC would be 86. Okay, so angle JKL. So this symbol becomes really important because JKL is also an arc, so JKL is this arc, but they actually have the angle symbol here, so they actually want JKL, which really is angle K, with JL as J and L as the two endpoints. So really the angle actually is going to tell you what the endpoints are. So it ends at J and it ends at L. So we want this arc though because this angle opens towards this arc. So if we can get this arc, we can cut it in half and get the angle. Okay, so we know the full circle from L all the way around to L is 360. And we know all of the rest of the circle except for the part that we want. So what we want to do is subtract the sum of these from 360. So if I add 65 and 53, those angles are 118 together. Subtracting that from 360 is going to mean that this arc from JML is 242. And then we would want to cut that in half to get the angle, so 121 would be the angle. Okay, RST for number 9 is this angle, and RUT is this angle. And they open up to the same arc. So this one opens up to RT, and so does this one, RT. So I'll let you figure out what RT is by doing the sum of the circle minus the ones that they already give you. And then again, if you get this arc, you need to cut it in half by the angle. So I'll let you figure those out. Okay, 10 through the bottom gives you some quadrilaterals inscribed. So we're going to be adding that opposite angles are supplementary to help us find the angles. So if you can find two that are opposite each other, they have to equal 180. I'm going to skip this one, and this one I'll come to this one. Number 12 is the hardest out of these three. So if they give you 39 is the degree here, 61. They don't give us any angles inside here, so we can't simply subtract from 180 because we don't know any of the angles yet. So we have to do what we were doing before on these and find an arc to cut in half to get an angle. So just looking at this, I have angle D is opening up to arc AC. Arc AC is a combination of 39 and 61, so I would add those together to get 100, and then cut that in half to get angle D. Okay, so angle B is going to be 50 degrees. Then for B to D, that arc is opening up from angle A. So if I cut off angle A, you can see that it opens up to the pink arc. So if I cut the pink arc in half, then that will give me a angle A. So let me just redraw this because it's kind of crowded on the picture. So angle A looks something like this, and there's other sides of the quadrilateral in here. But we're going for angle A, we're going from this point all the way to this point. So we need to figure out what this arc is so that we can cut it in half and get the angle. So from here to here is a 61 degree to this point, and then it's 147 to this point. So the combination of these would be 208 for this angle. And we need to cut that in half to get angle A. Okay, so that's going to be 208 divided by, so this is going to be 104. Okay, once you get two angles in a quadrilateral, then you're set, because if you know two of the angles, like let's say we only knew 70 and 85, to find the other ones you would subtract from 180. So C is across from A, so you would subtract 180 minus 70 to get this one, and then you would do 180 minus 85 to get this one. So in this picture, 50 is across from the B, so that's going to be 180 minus 50 is going to be angle B. And then 180 minus 104 is across, that's going to be the measure of angle C. So A is 104, B is 130, C is 76, and D is 50. Okay. Alright, and I'll let you figure out the bottom two because they also have to do with the inscribed quadrilaterals. So that's your hint. So these five all have to do with inscribed angles, so maybe some of these, and then also inscribed quadrilaterals. So those are the two that you should be using. We went through the definitions on this side, so then on the back you're just completing some more problems. Now this one, number 16, these markings here mean that these chords are the same length. That's significant because if they're the same length, that means they're cutting off the same arc. So this arc should be the exact same as this arc. So this is 6x minus 20 as well. So then we have all three arcs, and we know what they should total, so we can just do all of them together. Equals 360 and solve for x. Okay, so that's just the hint to set up that one. Okay, 17 through 23, I'd like for you to try to, from the picture, name these, and you can reference this. Semicircle is the only one that's not on there, so I can give you that one. So the semicircle would be QS, and it's an arc. So Q to S would be half of the circle, so that would be the name of the semicircle. Or you can name it QPS, it's just unnecessary, because even if you did QS this way, it's also a semicircle. So QS is enough information. Then you have some more of the inscribed angle ones. Okay, and then when we get to 28, it changes. So then we start to use some of these interior angles things. So we have intersecting chords or secants that they don't meet in the middle. So we're going to be averaging the arcs they open up to and adding them and dividing by 2, which is averaging them. So 28, if we're looking for angle AED, that's this angle, it's going to be the arcs that it opens up to divided by 2. Okay, and the rest of this I think you can figure out. We've done some similar to that. Okay, and then on the back, we are, the ones that meet on the circle are going to be like this case here with the intersecting tangents and chords. So we're going to basically be taking, for DEG, we want this angle, we take half of the chord that it opens up to, so, I mean the arc that it opens up to, so we take half of 308, so this will be 154. On this one, they want this angle, but they give us this arc on the side. Oops, I'm sorry. Can't even see that. So again, we did 308 for this, and we divided it by 2 to get the angle. So we're using this 6th formula for these 2. Well, these 4. Okay, so if we get the rest of the circle, 360 minus 192 will give us the rest of this, and then we cut that in half. Or you can figure out what this angle is by cutting 192 in half and then subtracting it from 180. Okay, so these two must make 180 together. So this would be 84 degrees. All right, and then all the last ones, well, not all of them, but a lot of the last ones use the bottom 3 formulas. So if the angle is formed outside of the circle, then you're going to subtract the larger arc, subtract the smaller arc from the larger arc. So large minus small, large minus small, large minus small, and then divide it by 2. Okay. Time is getting on, so I will let you try the rest of those on your own, and I'm going to flash the answers so you can just check to make sure you've got these correctly. Okay, so these are the answers for the first 9, for 10 through 27, and then 28 through 39, and then 40 through 51.